Alright, let's do another problem for today's problem set. We are going to be working on number 150, evaluate reverse Polish notation. Evaluate the value of an arithmetic expression in reverse Polish notation. Valid operators are those, and note that division between two integers should truncate towards 0, and it is guaranteed that the expression is valid. We will not have any division by 0. Okay, let's see. So our first example is this one. So 2, 1 plus 3 star. So 2, 1 plus and then 3 and star. Okay. So my first thought is use a stack. Smiley face. The approach that I would take in this case is that what we would do is that if basically for each token in tokens, if the value is an operand, so a number, add to the stack. If the value is not or is an operator, then pop the last two elements from the stack, evaluate, and put the result back onto the stack. So basically 2 here gets added to the stack, 1 gets added to the stack. We plus, so we pop 2, 1 and 2, we add them together. Then 3 we add to the stack, so now 2, 1 plus, we have 3 on the bottom. We have another 3, and then we multiply. I guess the main thing to watch out here for is the order of the operations should be kept in mind. We obviously, some operations like plus and minus, or sorry, plus and multiply don't matter which way they go. However, subtraction and division very much do care about the order in which the numbers are used. In this case, the runtime would be O of n, where n is the number of elements within the array, because we had to scan through them all, right? Yeah. And I guess that there's a small overhead when it comes to elements in the stack and whatnot, but I don't think it's a huge deal. And then the space is a good question. There's probably a little bit of research that can go into this, because the idea is that if an expression is valid, then I think that there's always a guaranteed maximum of elements that we can keep within our array, or that we will keep within our stack. So I'm not really sure about the actual the detailed space, but what I can say is that it will never exceed and I hope that it's pretty obvious. It will never exceed the number of elements within our array. So I'm fine to say that it's O of n, again, where n is the number of elements within the array. Because even if it is a completely malformed expression, and it's all numbers or whatever, then it will never exceed the amount of elements that are in our stack will never exceed the number of elements that we have in our array. This is fine. I'm just thinking, because it's like, it feels too easy to be a medium problem. But I'm going to get started on this approach, and we'll see if there's any sort of optimizations that we can make. Though I'm not too hopeful, because I can't think of really anything that we can optimize in this approach. We'll see. val stack is equal to mutable list of this would be a char. And then tokens for each character. When character is plus, let's just add them all here for now. We'll put the sort of in place ones first. This one we can just say stack dot add char. We would do stack dot let's see. First does not remove it, right? First, I don't think actually removes the first element. Returns the first element. How about, is there a second? I believe that there is a second, but oh wait, no, I'm going in circles. Okay. In that case, we can say val first is equal to stack.first stack, and can I just do remove at 0? And then val second is equal to stack first move at 0. Actually, we can't do this because this return value is a char, so stack. So we'll have to do this. This is not quite an elegant solution, but we can talk about elegance later. Or we can consider we could also do this as an int. And we can convert those integer dot from string, right? String. I just realized that we have numbers that are more than one character, so that is the case. I think it's integer from string, I think is what I'm looking for. Could be wrong there. First plus second. So technically this is the most recent element, so that should be there, I believe. This should technically be second and this should be first. But for me, I'm just going to put them in the order in which they come out, at least for these. Yeah, I'm just going to leave them as the order in which they came out of my stack. So lots of code reuse here, but oh, this is division. This is subtraction. This should be second. This should be first. Because we do 4, 13, 5. Then we do 13 over 5. So it's the second divided by the first. And then we add that back, and then we add. So definitely not a super elegant solution. Can I do like a take? What does take do? It returns a list containing the first n elements. We could do a take 2 and then index it, though that creates an entirely new list, and I'm not sure if that's sufficient, but it'll sure as hell look better. Oh, and we should probably should probably return after this stack.first, because after we finish these operations, so it'll be 2, 1 plus, so we add 3 to the stack, then 3 push to the stack, then 3 times 3 is 9, we push that to the stack, and then we return the first, or the top element in the stack, which should be our result. Let's see, let's go through this line by line. So we create a stack, which is a mutable list of integers, and we're going to be converting it there. So we go through each element within our array. These are strings. So when the string is, and I worry that Kotlin will complain because I'm doing this in single quotes rather than double quotes. So we take the first element, we remove, take the second element, remove, apply operation. Same thing here. This is copy and paste the code, so it should be the same. With the subtraction and division, we need to be careful because we are always doing the first element operation, second element, or rather the second operation first because of the order in which they're added onto the stack, or a pseudo stack, I guess you could call it, right? Is there anything that I'm missing? No, I really don't think so. Yeah, no, I don't think I am. Let's go ahead and run it and let's see what happens. Oh, from string is not valid. Oh, and this is string. From string is not. What was it again? Oh gosh. Java docs integer. Is it parse int? Really not sure. I think that parse int was actually JS, but hopefully they use the same syntax. Okay, cool. And it seems like it worked for the first one. Let's just run it through the gamut of all the test cases. Ooh, interesting. Oh, that's weird. That's weird. 13 divided by 5. Why is this not? Should always truncate towards 0. I think that's where it's wrong. What do they actually mean by truncate towards 0? Let's see. 13 divided by 5 is 2, right? It's 2 point something. Let me actually print second divided by first to see what this comes out as. It should come out as 2, but I don't know, maybe Kotlin does rounding rather than... It does do rounding. That's odd. Is that intended behavior? Or maybe my Java knowledge is not correct? Does Java truncate? Round integer division? I was not sure of this. The result is truncated. Is this different? Integer division. Division of integers always returns in the fractional, any fractional part is discarded. If that's the case, why is this different then? Unless this is Kotlin 1.7. Was Kotlin 1.3 different? Or maybe there's... What? I'm not crazy, right? No, this is 13 divided by 5. It's returning 3. That is weird. What? It says here division... Sorry, where is it? Division of integers, any fractional part is discarded. Okay, I'm opening this in Playground and making sure that I'm not crazy. Okay, what? JVM 1.3. What do you actually return? Don't tell me... Okay, if this returns 3, then it's... Then I guess they changed the behavior, but... Let's see. No, it does. Huh? Sorry, am I going crazy? This is... Or maybe this is if maybe the stack or maybe the item that's being added is incorrect. What is going on here? Okay, so it's not that it's probably something else then. 13 and 4. Where's 5? Why is it 13 and 4? Sorry, it should be first and seconds. The first one that we pulled out was 4. Oh, it's first. We are not operating in a stack-like manner in that case. If we add it at 0, then it would, I think. Yeah, I think it would act like a stack if we always append at 0. Add. Does add not let us? I'm pretty sure add lets us. Let's see, collections. We'll do a mutable list of. That'll get me what I want. Add. Where are you? Oh, you probably want a mutable list. Add. Oh, it's index then element. Oops. So by adding it to the front, then we should get a stack like. Because it'll be add. Give it a toss there. I always forgot about that. No, this is ooh, interesting. Let's see, 10, 6, 9, 3. Then we add 9 and 3. Oh, whoops. Need to also implement that sort of stack thing. This might actually be a decent use case for using a linked list from Java. I'm gonna actually give this give the linked list a shot if the if it turns out that this is like in particular like super slow or super memory hungry. But it's not, and this is the solution. Why is this a medium problem? This is just like use a stack. I mean, I was stupid and I used a list and I had to insert at the 0 index. But why is this a LeetCode medium? I don't know. Maybe there's some additional complication to it, but or maybe I'm just like really familiar with reverse Polish notation because I've seen this type of problem before, but like this doesn't feel like a medium to me. There's not really a lot of nuance here. You add elements to a stack, you pop them from the stack, and then you add them to the stack. My runtime is all right. My memory usage is all right. It's just I don't know, but I don't know. I'm glad I got through it. Yeah, and in any case, I guess I'll just leave it here then because it's fast enough. And from the last problem, it seems like using a linked list might make it slower sometimes. So I'm not going to mess with the magic that is Kotlin. But in any case, I hope you learned something, and I will see you for the next problem.